Welcome! So we're going to review concepts from the benchmark in this Nearpod. And some of these are going to maybe new to you. Maybe we haven't gotten to them yet. This will help you do better on that benchmark, all right, and help you feel a little more confident. All right, so first of all, we're going to go over, and by the way, I'm going to post this PowerPoint. Some of these slides are in your notes. This one in particular is in your notes, but I'm going to post this PowerPoint. Feel free to print it out and use it however you want. All right, so methods for showing triangles to be congruent. So first one, side, side, side. If three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent. All right? So if you've got three corresponding sides, that is enough for triangles to know that they are congruent. Side, angle, side. If two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. So the included angle has to be the angle formed by the side. So the angle has to be in between those two sides. Right? That will be enough to prove the triangle is congruent. We have two more that can be used on any triangle. Angle, side, angle. Right? So it's kind of like side, angle, side, except instead of two sides and the angle between, it's two angles and the side between. So if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. All right, so now if you can use these when you're trying to figure out congruence, you look to see if if there's any shared parts, you can mark those. You look for parallel lines, you can mark alternate interior angles. Vertical angles can be marked congruent. It's hard to get many sides congruent other than if they happen to be shared, or if there's a midpoint dividing the side in half. But then you can, once you've done that, you can look at these diagrams and see what it matches. All right, does it match one of these? So angle, angle, side, angle. So angle, side. So with side, angle, side, that angle has to be between the two congruent sides, but it doesn't have to be with angles. Right, and we'll talk about this, but the reason is if I know two angles are congruent, we learned third angle theorem. The third angles have to be the third pair of angles have to be congruent as well, right? And so anytime you have angle, side, angle, you technically, boy, those arcs look terrible. But anytime you have angle, side, angle, you also have angle, angle, side. All right? And that's because, I'm going to add this here, third angle theorem. And I'm going to erase those arcs because I want you to be able to focus on just what angle, side, angle looks like in angle, angle, side. But third angle theorem states if two angles of a pair of triangles are congruent, the third pair of angles are also congruent. All right, and that's third angle theorem. All right, so either it'll pop up now or I'll have two of them. Or maybe it won't pop up at all, I don't know. I'll read through that and I'll see if it, I don't think it's going to pop up. Is it? Oh, there we go. I don't know, if it doesn't like that spot. Are also congruent. All right, so we only have side, angle, side. So if it's two sides and an angle, it's got to be the angle between. But with two angles, you can have the angle between, you can have the side between, or you can have some other side. All right, so angle, side, angle, if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. If the side is not between the two angles, that's okay. It's angle, angle, side. If two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. We have one more. You really won't see it much. I don't even know if it's at all on the, I think it's given as a choice, but I don't think it's actually The questions are focused on this, but the last one is hypotenuse leg. And hypotenuse leg is only for right triangles because only right triangles have a hypotenuse. So if the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. Either leg of the right triangle may be used as long as the corresponding legs are used. So hypotenuse leg is for a right triangle. So if you forget that one, you can always look at this chart again. Let's solve a few problems. And I tried to write ones that would be similar to what you would see, so you would have some review beforehand. And we're just waiting for the page to change. Any day now. So while we're waiting, in this video, this video, by the way, is just going to be, oh, here we are, congruence. And then we'll look at other concepts in the next videos. Which postulate theorem would be sufficient to prove triangle AEB is congruent to triangle CED? Right, it's not important to you whether it's called a postulate or a theorem, right? So long as you know the basic names of these. All right, so now you should see you have a pair of corresponding angles, right? Let's write this out just to make sure everybody sees it. So angle C is congruent to angle A. Right? And, excuse me, side I still have my pen up. Oh, there it goes. Sometimes it doesn't like it if I try to erase when I have a pen in my hand. And we're given, so AE is congruent to CE. So these were given pieces of information. And you're not going to have to write a proof on the benchmark, not on triangle congruence anyway. But you should, I don't think so. You should be able to follow this proof so that it can help you understand which triangle congruence postulate it is. Now, make sure that you take a look for these types of things. And you know it would be helpful if this is on the computer and you can't write on the computer, right? Draw it out so that you can mark these. Because if you see it, I think you'll get it. All right? So we see we have angle CED is congruent. I don't have enough space here. I'm going to move this over a little bit. Oh, no, I'm not. They're connected somehow. I guess it depends on the order I wrote things in. There we go. All right, this stuff was given. And so we have angle CED congruent to angle AEB. And it's because those are vertical angles. Now, if we have three pieces of information, is it the right pieces of information? Well, I see I have two angles and I have a side. Right? Well, I will tell you first of all, this is not a congruence postulate. So if you see, if it's asking you about congruent triangles and you see angle, cross that one out. That is not it. All right? We have two angles and a side between. It must be that triangle AEB is congruent to triangle CED, using angle, side, angle. So the correct answer is C. All right? Now you don't have to write a whole proof out to be able to solve these, but I would draw it out, right, so that you can mark it and see, oh, I have an angle, right? I have an angle, a side, and an angle. That's angle, side, angle. All right, let's try the next one. Which postulate could be used to prove the triangles congruent? All right, so we've got, it's kind of hard, it's just a little blurry, I had to blur this up. But notice we have, we're given there that WU is congruent to XY, and that's given. We're also given, there's also, I don't know if hopefully you can see it, but I'll mark it darker here. We're also given some parallel line markings. So we're given that WU is also parallel to XY. Those both things were given. All right? Now, how does that help us? All right, well, we have parallel, when we have parallel lines, we have angles that are congruent. And it might be, I don't know if it's, might be easier if I extend this line a little bit so that you can see. Here are the parallel lines and the transversal. Or at least one pair of parallel lines. Well, excuse me, the parallel lines and one transversal. Right? So we know that when lines are parallel, certain angles are congruent. Right? So right away we see we have a pair of alternate interior angles. So angle WUV is congruent to angle XYV because they are alternate interior angles formed by parallel lines. But they're not the only pair because we have another transversal. So these angles are also congruent. So that was angle, I'll write that one in red just because I used a red pen there. That's angle UWV congruent to angle YXV. And same reason, so I don't have to write it again. And what do we, if we look carefully, what do we have? We have angle, side, angle. And I think I meant to write this when I wrote it. Postulate or let's, because there may be another one. Well, we said in the other slide, this is not a congruence postulate, so you can cross that one out. So now we're left with those three. Now this is not, there's no writing markings that this is a right triangle, so you can also cross off hypotenuse leg. But something else is also congruent. And the other thing that's congruent is these angles here. So angle AVW. Wait, that's not an A. I'm looking at my angle side angle thing there. UVW is congruent to angle, I started with U, so start with Y, YVX, because they are vertical angles. And we know vertical angles are always congruent. We also could say they're congruent using third angle theorem. If two angles of a triangle are congruent, the third angles are congruent as well. So not only could we use angle side angle, we could use, if we're using this angle over here, we could use angle, angle, side. So both of these are correct. And actually, any time that you can prove angle, side, angle, you can also prove angle, angle, side. Those two go together. All right? So I know that's a little tricky, but hopefully this is going to help you understand that just a little bit. Just a little bit better. All right, now this is really similar to a problem we did in class. Which postulate could be used to prove the triangle's congruent? All right, so you're given RS is congruent to TU. You're given RU is congruent to TS. What else is true? Well, RT is congruent to TR using the reflexive property. And that means you've got 3 pairs of corresponding sides congruent. This is side, side, side. Right? That one was pretty easy, I hope. Right? So look for those shared shared parts. You can always prove they're congruent. All right, let's look at this one. This is kind of like one we did in class as well. Complete the following. All right, so we're given that I is the midpoint of ME and SL. All right, so if, and I'm going to actually do this one as a proof. I'm going to write it out here. And so actually this, we're determining if these triangles are congruent or not. And I will tell you the answer is yes. Let's take a look at the whole proof here. All right, so here's our statements and reasons. All right, and so first of all, we're given I is the midpoint of ME and SL. And that's given. Well, what does that mean? Well, what does a midpoint do? Well, a midpoint divides a line segment in 2 congruent parts. I'll put segments because the parts are segments. I wasn't sure I could squeeze it in there. All right, so that means, so it's a midpoint for ME. That means that MI is going to be congruent to EI. And it means SI is going to be congruent to LI. Now, if you're not able to write a proof on this yet, that's okay. But if you see that something is a midpoint, remember midpoint divides a segment in half. All right, and divide that segment in half. All right, now we only have that's 2 pieces of information. We need 3. But remember, these are vertical angles. So angle MIS has to be congruent to, move that down just a little bit. Has to be congruent to angle EIL. And we know vertical angles are always congruent. So now we know that triangle MIS is congruent to triangle EIL. I guess I'll put it in my proof as well. And our postulate is side, angle, side. That one's a postulate, but it's not really, it's a small deal whether it's a postulate or a theorem. Theorems are formed off of postulates, are proven using postulates. So long as if you write postulate or theorem, I'm fine either way. And if you just write side, angle, side, I'm still fine. All right, so our theorem was side, angle, side, and I think I'm all right in triangle congruence because I haven't got any more space there. All right, and so hopefully you're understanding just a little bit more about triangle congruence, and we'll continue to work on it. And I think this is my last one. Select all that would be needed to be state all that would need to be true to show the triangles are congruent by side, angle, side. Well, we don't have a whole lot here. We have one thing. Because there's no markings, the only thing I know for sure is that YZ is congruent to ZY. That's it. That's the reflexive property. So we're going to use that. And then what else would have to be true? Right? Well, we're going to need another side. Do we got it? Does it list another side here? Let's see. It lists x, y, and yw. All right, let's mark that. Well, if that's going to be the side, we're going to need angle WYZ. Okay, there's WYZ. And angle XYZ. There we go. All right, so we could prove triangle, the triangle's congruent using side, angle, side, if x, or is it xy, was congruent to wy, and xyz, angle xyz, was congruent to angle wyz, the y angles there. All right, let's see, is there another way? I don't know, I'll mark this. So angle x congruent to angle w. Well, look at, that's not next, that's not formed by my side. All right, so for this to work, the angle, for at angle side to work, the angle's got to be formed by the congruent sides, and that angle is not formed by side YZ. So this is not it. So I'm going to cross that one out. YZ congruent to YZ. We already know that. That we don't need the, we don't need to know that to be true. It is true, right? It says select all that would need to be true. Well, this is true. Right? That is true. Well, that is sloppy. That's what I say. That is not much better, but it is true. And then the other angle, XZY, that doesn't help us. That's not, we don't have another side to go with it. All right? So this would be the answer because only that combination works. So I started looking for a side first, figuring I got 3 angles there. If one of those 2 sides works, then we're good. All right, and actually the other side wasn't a side. It was the reflexive property. So we had to use x, y, and wy, and then what else goes with that? Well, that's the end of my congruence postulate video. All right, in the next video you'll see, I believe, triangle similarity. All right, so thanks for watching. Bye for now.